Okay, you are clapping and I'm getting like nervous. So let me introduce myself. As I'm Keshav Agrawal from India, and I work for Plivo. I'm a DevOps engineer there, and this Python memory management talk I chose because when I joined Plivo, even I was new to Python, and what I liked is how very simple things I'm going to talk about, not much because even I consider myself still a very newbie to Python. So okay, so the first question I think everybody would like to know is why I would like to know about Python memory management. What is there to know about, and why I would like to know about memory, how Python manages memory. So it's very simple. The intention is very simple. Whenever you are going to write any program which does a bit more than just printing out anything after doing simple calculation, if you are going to write a big not website, I wouldn't say website, like kind of you use Django web framework for creating a website. So whenever you are going to write a big application, many things start coming to your mind, like how my variables are declared. Am I doing something which falls into the loop and using too much of CPU cycles? So how can I optimize that? And if declaring too much of same variables which holds the same value is worth it. So these things does matter when you are writing a big application. So let me, okay, the very first slide is just simple, like why do I need to know about Python memory management? Because the very obvious reason, you don't want your program to slog, and if one part of your program is taking too much of time, you don't want that to affect other parts of your application. So it's pretty obvious that I want to handle my memory very efficiently. And of course, when you know what's happening inside like how memory is getting managed, it helps writing applications in a very efficient manner. So I think these three are the very obvious reasons why you want to know about memory management. In any language, actually, it's just not about Python. In any language, you want to know what a language is doing, how it's compiling, how its variables are getting declared. Okay, so if we talk about variables in Python, so it differs a lot how it gets declared in other languages and how we declare in Python. So suppose if you are declaring a variable in C, kind of into my first variable, I'll show you. Actually, better to, rather than speaking at an interest. Sorry. So like in C, if I declare int C is equal to 20, and again I declare another variable in some other program as int D is equal to 20. Actually, I'm using C and D. I know that's not a good program practice. I'm just giving an example. So what C does, it allocates two different memory for holding those two values, 20 and 20, in two different places. So you are having same value but two different memory allocations. That's kind of eating double memory, and we don't need that. So how Python handles it? Python is just a kind of say oops, sorry, I went to C. So here what Python does, it actually doesn't declare two different memory for holding these two values. It has declared only one particular memory which holds a value of 20, and any variable which holds the same value, it actually tags, kind of you can use it, tags that particular memory to these different variables. So there are so there are not two different memory allocation for 20. They are just reference that okay, when I say my first variable, it will pick up the value from that particular memory allocation which holds 20. So how would you check that it's actually one particular memory location which is holding 20 and there is no two different memory allocations. So you know, if you okay, sorry, yeah, there you go. So if you see that this is the value, and if I do it for the same, here you go. So we don't have two different memory allocation, we just have one memory allocation which does the job for two different variables here. So this is this creates a big impact in making a difference from C and Python, and because we are using less memory. So imagine in a big program you must be using so many different calculations, you must be doing so different many different calculations, you must be having similar values. So what if a program does, you know, creates a list of range of numbers in which around 100 are of same values. So rather than creating 100 different memory allocation, Python will have just one memory allocation for that. So it's kind of 1 by 100. Yeah.
How about the second number is say 20.0 is a float number.
Okay. So yeah, in that case it will create a new value. So why not do it here only, say something like that.
The point was I just wanted to see 20 and 20, so we consider that the same, but Python doesn't. So that's the point was, I think 20.0 is the same as the integer 20.0. That's the nature of the question, right?
Oh,
no,
okay.
yeah, but we consider that the same, but Python doesn't. One's a float, it's a different type, but we still treat that as a separate value, even though mathematically we say
They are same, but the type is different here. Yeah, it's a new memory allocation. So okay, so this is just says like it's a reference, no type is associated with that, and it's just a fancy line there that don't clone me, instead tag me. I mean, it's just a variable says okay, if you have same variable, they don't need to clone you and duplicate the same value and create a new memory allocation for that. Okay, before going there, I would like to one more thing. Like generally we use range function very frequently in our programs, like range of creating one variable, sorry, not a list of numbers, say 1 to 10. Okay, so like if I do oops. Okay. So range is actually, you know, it's heavyweight in comparison to, there is another function which is x range. I think you guys know about it. So what is the difference between range and x range when coming to writing a program? So I think it would be better if you use profiler, and you use profile on writing two different functions, range and x range, and then you will actually see that how Python memory is getting used up when you actually use range and when you use x range. So again, I would be writing one simple program which would suggest that I think I already have it. Okay. is not needed. Just say this. So here we are doing exactly the same thing. I mean, looping around the range and just doing one simple operation, nothing doing, actually just count is equal to 0 every time. And similarly, we are declaring here this function which does the same thing, but it just we are using x range here. And okay. So and I'm going to call these two functions. So let's see how much memory impact. Sorry.
It's just range underscore.
Okay. Thanks for that. So let's use memory profiler as a module of Python. Okay, it's nice. Okay. Actually, that screen is not filling up. I mean, I just did Python -m. So here you have. If you can see that x range while executing this, the increment in the memory usage of the system is just 4 MB here. But for this function, which was using range, we see around double of memory increment which we are using, which we encounter when we are using range. So this is just an example. So which shows that exactly double of memory we use when range is used, and when in comparison to x range. So you may not feel the impact of it when you are writing a very small application, but when writing big applications, like when you then you actually feel the impact of it when these eats up a lot of memory, like 100 MB of RAM, or 100 MB of memory, or 200 MB of memory. I've seen the implications of that when we write code in our company as well. So just wanted to show this thing as well. So profiler is very useful tool to judge your memory allocations, how your program is performing. So you just need to import this memory profiler module. And then just it provides a very decorator @profile, and you can measure your memory. So this was about range and x range, and another example would be when we go to strings. Okay, so while before coming to Python, I was using Java as well. So in Java, I used to always, while coming to concatenating of strings, I used to use different strings and using plus operator, and then you do concatenation. But coming to Python, it actually hurts when you do that. So if you I thought that okay, it's just a 2.7 Python 2.7 which does that, but even in Python 3.3, if you look at the source code of Python 3.3, it clearly will tell you that that if you do a concatenation of two strings using the plus operator, it actually is creating two different objects every time you concatenate, and it allocates memory for that. So if you are doing a list or if you are doing a concatenation of say 100 different strings, so it's actually creating 100 different objects every time. So that's kind of, we don't need actually, because the only thing which we need is the last object which got created, the concatenated part. So rather than using string A is equal to string B plus string C, string A, I mean A is equal to B plus C, where A, B, C and strings. So you can, if you have the list of strings already in your hand, then you can use better this join, which actually count the length of the list. Like if I have 100 elements in the list, it will count the length of the list, and then it will allocate accordingly the memory that okay, my last string is going to be of this length. So and then finally it joins them. So yep. So this using dot join is more efficient than using plus operator. I think even for this we can have a simple example.
Okay. What about use %s for strings? Okay. Okay. Is this the same like plus or
no,
save more memory? Just substitute.
I would like you guys to answer, because I'm not that clear, to be honest, for that %s how it's, but it's definitely better than concatenation operator. But I'm not sure on join and plus this %s. Anybody who knows the difference on that?
No, that's also a substitute will work as same as plus operator.
So it uses the same memory? Okay. It's just a different way of doing concatenation. Okay. Thanks for letting me know as well. Because as I said while starting this presentation, that I am just a newbie who started to learn Python. Okay, so there, like generally, if you are writing a Python program, you don't need to do garbage collection, because Python handles that pretty efficiently on its own. But sometimes what happens is okay. Let me tell you about reference counting first. So suppose an object, you create a string or a list. It creates an object for that, and the Python searches if that object is being referenced anywhere in the program or not. So if the reference counter, it holds a reference counter for each object. So if that reference counter comes to 0, it deallocates that variable, object. It frees the memory for that. But what if for some program it goes into you write a loop kind of thing, which which refers the variable inside itself. So the reference counter will never go to 0 for that. So you are stuck there to to free the memory. Python is stuck there. So then garbage collection comes into picture. I'll show you one simple program for reference counting, how that loop thing falls into picture, where it will never go to 0. And yeah, so garbage collection. Okay, so there is a threshold value which every Python manages. It depends upon your system actually. So you can actually look at it by running a simple Python provides a function for that, where you can check what is the threshold value of when it will initiate the garbage collection. So okay, better to write a simple program and show it. Oops. I think, yep. So if you see this function here, memory cycle, this particular function here, so this is just creating and it is referencing to itself. So the reference counter for this particular object will never be 0. So reference counter for this will never be 0. So this will be stuck and it will never be cleaned if this is not being used. So suppose that this is a remote function, we are done with this, we don't need it, but still the memory is there. So to illustrate that, we okay. So before this, I think, sorry. It's actually not necessary every time to do this garbage collection on its own, because if you do it too frequently, then it actually it's a overhead on Python as well, because it actually uses a lot of memory to find out the free memory to calculate whether it can be removed or not. So if you are doing that too frequently in a program, it actually increases the memory usage, it does not clean up the memory. So use it very wisely when you think that okay, it's a function call which I would need only when my application is starting up and the kind of initialization and all. So after that I will never need this function, and you think that function is going to eat up a lot of memory because of different big objects like lists and dictionaries getting created. So you can use after that particular function that okay, gc.collect free up that memory. So it's a the warning comes up when people say that use gc.collect, that don't use it too frequently in a program. Oops. Oh, I have used profiler in that as well. Excuse me. Ah, sure. Better I just print it. Ah, I missed that bracket, another bracket there. So if you see this is the threshold value. 700 is the threshold value for that garbage collection. And so initially when I did collect gc.collect, it didn't collect any it didn't clean up any memory, it didn't collect any garbages. So it just shows collected is equal to 0. But after running that one function which was here for I in x range 1000 make of cycle, which was yeah, then if I do a collector of gc.collect and then print what got collected, then it says 305 objects is cleared up after this function. So it helps to know to know that okay, so I was eating up 305 objects which was not needed, and which was there in the memory lying up, which was not needed or was not referenced. So there are times when you want to use manual garbage collection to be included in your application, and not leave to Python to do it automatic garbage collection.
So why isn't there a decrement between 20 and 22 if you collected it? Sorry? Between line 20 and 22, the total memory used. So you've done a garbage collection, which was at 8.7 meg. So by the time you get down to the print, you've got rid of all the garbage, which was from the loop, but you're still at 8.7 meg. So it's told you I've got rid of 305 objects, but it hasn't released any memory.
Yeah.
Okay, so
It should be a difference there if it's like that.
okay. So I think I can answer your question. So there are different level in which memory allocators work on your system. Like system OS has its own memory allocators, and where Python has its own memory allocators. So when you do this, Python frees the memory, but it actually doesn't release those memory to the OS. Okay, so it holds it holds the memory free list on its own. So this actually shows you the OS memory usage here. So the memory has not yet been released to the operating system, because it still is held by the Python memory allocators, but it's free for your program to reuse.
What if you comment out the loop and see the memory?
So if you're saying if you run that loop again after the memory collection, then memory usage shouldn't go up, because to demonstrate that point. Because you're saying Python got to grab the memory, so it's just going to be huge.
It's pretty weird. Although it takes less this time. But 200 KB, this time it took 100 KB.
Doesn't have to do with the 305 instead of 1,000 objects. Maybe the 305 has nothing to do with volume.
Okay. So if anybody knows a better answer for this, I would love to know this.
Bigger numbers, more create destroys before they start releasing. Maybe it's too simple.
The print statement isn't garbage collected. How did that be done?
But that wouldn't be held. That just would be output. That's not.
But it takes a while for garbage collection to continue, so maybe it's still there once you're doing it.
What if you use weak reference, like a proxy, instead of a hard reference?
So I didn't get your question.
No, right now you are in the next cycle, you use hard reference.
Okay.
I mean, what if you use weak reference? That one, you're pointing to yourself.
Uh-huh.
I mean, what if you use weak reference? Does it make any difference? Using something like a proxy.
Okay. I am not getting what do you mean by proxy, but saying.
Yeah, you have to import with clamp.
just return something, I think. I mean, not self-referencing again. That's what you mean?
Yeah, because you're creating a cyclic object,
Correct.
right?
Correct. Mm.
And you're using hard difference. And
so here there is no cycle, right? I mean, yeah. Or do just anything, return anything. So no cycle, right? So this time it didn't clean up anything. It didn't find any. And this time, if you see that this, which we were talking about earlier, this value has increased as well. I mean, earlier it was 200, and then half of it was used, like 100. Now it's just 0.47 to 0.78. Actually, the reverse. Okay, this was not supposed to be there in the list. But, okay, it came into the. So this is what just the. I mean, that is what I found when starting learning Python about simple things like variables, string, range. When you create list of numbers, creating so many objects, it happens when you are dealing in another language. But Python has better way to use every memory, and so I thought that it would be better if I bring this out. Most of the people know about it or have read about it already on websites and different. But I thought that it's better to present a different present it with examples using showing profiler sort of memory. We can see live that how many memory is getting allocated or deallocated, how much memory is getting used. So that's all for this short talk. Any questions? Yeah.
Were there any cases where you found manually tweaking with the garbage collector's behavior beneficial for your program or your application?
Yeah, so Python does garbage collection, not every time it doesn't do that. So if you think that you're using your profiler, also you can know that how much memory is getting allocated, and if you think that's that part of the that particular function which was used just for simple process or some kind of initialization while you're running application, and that is not needed anywhere else in your application. So rather than waiting for Python automatic garbage collection to run, you can call yourself and do manually that manual garbage collection, so that it frees up the memory.
I think my question is more towards were there any issues that Preview faced when you actually ran Python without manually tweaking the garbage collector and ran into issues and hence had to actually dive into the garbage collector's behavior to change it such that it fits Preview's needs better?
Saying you encountered an issue while doing that have you?
As in, like, because usually when we program in Python, we tend to not want to have to care about such low-level issues until it starts to hurt us. So, like, were there any cases where it actually starts to hurt you?
Okay, so I'll tell you where I actually encountered this. There was we happen to have a cron job running in our application, which it just generates the invoices for different customers every month. Okay, and there are certain other cron jobs which does balance kind of audit while in our application. So one simple example would be like Pleo.com that we have a lot of customers, so we have to run invoices every before just the end of month. So that cron job has certain initializations and certain DB fetching needed before my cron job actually starts running. So after getting those things, we actually we never needed that particular function. So what we saw was it was actually using around 348 MB of memory, which actually doesn't impact when you have when you are having a 8 GB of RAM. But it does hurt when you are running a very small cron job instance, like you get an instance from AWS and you don't need other stuff, so you just have a small instance. So you don't want to load your memory with the applications, the functions which are not needed. So we just ran this one simple profiler on our application and saw that where exactly this is taking memory. So we saw that, okay, after DB fetching, we don't need that part, and it's actually eating that much memory. So we ran that gc.collect, and there were other couple of parts. So we saved quite a bit of memory and the speed to by running gc.collect.
So you actually saw improvement in the speed.
Okay, I'm afraid I have to interrupt you there. We're running a bit short of time. So a round of applause, guys, for